Welcome to my channel. I'm Zhang Xu. Let's look at the problem 59 in chapter 13. Chapter 13 is about the fluids. Still, we have these systems, right? We need to show the Bernoulli's principle can find the V2, the drop at a rate dH dt equal to this function. And A1, A2 is a cross-sectional area. So we consider this is position 1, this is position 2. Now the drop rate must be V2. Do you agree? So it looks like we need to find V2. So in this system, first of all, we consider the continuity equations. We can see the water volumes moved out from position 1 must equal to the volumes of water moved drops at position 2, right? So we have A1 V1 equal to A2 V2 because we need to find V2. So that means we can write this equation V1 in the function for V2. Then we put it there. Second time, we can consider Bernoulli's equation. So Bernoulli's equation, the situation in position 1 equal to position 2. And in position 1, we can see it connected with air. So this is air pressure. 1/2 rho V1 squared plus rho G Y1. And then P naught, because it's connected with air, so P naught plus 1/2 rho V2 squared plus rho G Y2, right? Now we can see the P naught can cancel. So now we can find the equation look like this way, right? We write it in this way. Y2 minus Y1 is H, and rho can cancel. So now we have V1 squared equal to V2 squared plus 2GH. Now we can see V1, we input it there inside. So now you can see this is the equation for V2, and very easily we can solve it. We get the V2 equal to this equation, right? And then the drop at a rate dH dt must equal to negative rho V2. So now we proved it. The second time we need to find the h as a function of time t by integration. By do the integrals. So we can see now we have a dH dt equal to this equation, right? So in this function, you can see at this side we have h, so we can solve it. So we move the squared h at this side, move the delta t at this side, no problem, right? Now we do integral as both sides. At initial it is h naught, and then it becomes h at time t. So initial t equal to 0, h naught at time t is h. We do integral as both sides. Finally, we get the function look like this one. So this is a h as a function of time. The next one asks you how much time it takes to empty it, right? So now it gives you some quantities. R1 is given, so you can get the cross-sectional areas for A1, right? This is 0.25 meters because it tells you the diameters, you can get the radius. And H naught is given, right? Initially tells you it is 0.106 meter water, this is a tube. And the next one, the volume is given. The volume is 1.3 liter of water. So in this one, you can get A2. A2 is just cross-sectional area equal to V over H naught. Now we get H1 and H2 from these two equations, right? And we want to empty it, so that means H becomes 0. H becomes 0, so that means the terms inside become 0, so we can solve it. We get the t in these functions and input A1, A2, and H naught. We get the final answer 92 seconds. Thank you.